monomer. So this is a little background. It's an organic compound and it's considered a very important raw material for the industry because it's used in manufacturing of other materials that are marketable. Most of this styrene produced is manufactured into polystyrene, and others are ABS, SAN, SPR, SPL, which are all styrene-based materials. Next is our market survey. So we started with the world and local demand for styrene. This chart shows the world demand for styrene, and as of 2020, the world demand for styrene is about 40 million tons per year. As for Malaysia, the national demand is about 340,000 tons per year. So these are the key players with the chemical companies and their capacity per year, with the highest being styrene solution with a chemical capacity of about 2.5 million tons per year. So this is a chart of a spot price for the styrene price for 2020. So the average for this year is about $900 per ton. Then after looking at the production statistics, the team decided on a production capacity of about 73,000 tons per year. Thank you.
For the site selection, we compare three places which are Kerteh, Butterworth, and Pasir Gudang, and finally we propose Pasir Gudang as the best place to build the styrene plant after consider all the factors. For the raw materials, benzene and ethylene can get from the Titans, and then for the ethyl benzene we can get from the Dimension company. For the water supply, Johor has the minimum water supply charges compared to other two states, and also it has sufficient energy availability. And the workers who are work in Pasir Gudang area as a monthly wages 1,100. And then for the Pasir Gudang as a best place because it has a three in terminal spots which can ease the production. And also it has a biggest market availability around the site. And also Pasir Gudang has a proper waste management and also the charges also very minimum. That's all from me. Thank you.
There are three possible reaction pathways to produce styrene. The first one is dehydrogenation of ethylbenzene, at where it involves the catalytic reaction of ethylbenzene, and the byproducts are produced in this are coke, benzene, and toluene. The operating pressure is 35 to 100 kilopascal. The temperature is 530 to 650 degrees Celsius. It is 65% of conversion. While the second reaction is the operating condition is 90 to 150 degrees Celsius and 8 megapascal. The conversion and selectivity achieved is 92%, and the byproducts produced are methylbenzene alcohol and acetophenone. The third reaction is the alkylation of toluene with methanol, at where the operating temperature range from 400 to 423 degrees Celsius and atmospheric pressure. The conversion achieved is 60% and the selectivity is 90%. The byproducts produced are hydrogen, carbon dioxide, and ethyl benzene.
So hello again with Maad Ahmed Saleh process reaction. After discussing the process synthesis with my friend, now we are going to discuss how to choose the best reaction among them. So some information is obtained from the articles, and we have done the tables of advantage and disadvantage of each reaction. Then we calculate or we obtain the prices of each chemicals that include in the reactions to do the economic potential calculation. In this step, we get that the first bad reaction is the best reaction in the gross profit. So we have done the rating by using the weightage. We choose that and we obtain that the first reaction is the suitable for our
The
production.
first step is to eliminate differences in molecular types. This is basically us evaluating and ranking all the reaction paths. So after this, the next we got this chemical reaction. This was what we decided to go on. So the next is to do the mass and energy balance, which we can use by using the styrene target as the basis for our calculation. And the energy balance, it can be gotten from the stimulator. Next is eliminate differences in composition, which is achieved by designing separation units, and these are the considerations we used. The next step is to eliminate differences in temperature, pressure, and phase, which can be done by designing utilities system. And finally, you integrate tasks, which is done by allocating appropriate unit operations. Then you integrate several processes together by using a single unit of. And finally, you favor the process that reduces
that
cost.
we choose in the task one, which is the best reaction. After using the selectivity and the fractional conversion of the side reaction and the main reaction, we here calculate the mole fraction of the output stream. Then we convert the mole fraction by using the molecular weight to the mass fraction. Then the output stream is calculated. So in energy balance, we use 25 Celsius is the reference temperature and 1 atmosphere pressure, and we neglect the kinetic energy and the potential energy. And here we use two formula, which non-reactive like mixtures and bump, and reactive like and reactive formula in the reactors.
The figure above shows the process flow diagram for the styrene production. It starts with the fresh ethybenzene and recycled ethybenzene fed into the mixture to be mixed with steam before it fed into the reactor at 600 degrees Celsius. The effluent from the reactor will be cooled from 600 degrees Celsius to 70 degrees Celsius before it fed into the three-phase separator, at where the ethylene will be separated from the styrene. The bottom product from the three-phase reactor will be fed into the first distillation column, at where the organic liquid is separated from the ethybenzene and styrene. The organic liquid will enter the second distillation column to undergo the separation process of toluene and benzene, while the bottom product of the first distillation column will undergo the liquid-liquid extraction process, at where the ethybenzene is separated from the styrene. The separated ethybenzene will be cooled and recycled back into the stream, while the styrene is produced at the rate of 8.48 megaton per hour.